Okay, so here we go. Section 6.3. We just talked about the reflection of light. Now let's talk about the refraction of light. So remember, the refraction of light, or in waves in general, is when you go from one medium to another and you have some bend that occurs. In light, you can see in this example right here, you're going from air to what appears to be glass and back into air. Look what happens, right? Clear bend that occurs. Okay, looking at a piece or a pencil in glass. Okay, light is hitting this, so you can see this, but it is going through water in this case, and you get some bending that occurs. Now, what we're going to talk about to start off is we're going to talk about something called the index of refraction, which is basically an index of all these different materials that will refract light at different amounts. So glass, for instance, might refract light more than water, or air might refract light more than, something else. It will be associated with a certain number, and the higher the number, the more light will be refracted. So in other words, the more bent it will be. The lower the number, the less it will be. So it's a unitless idea, and it's basically defined to be the speed of light in a vacuum over the speed of light in a medium. In other words, our control, or everything is in reference to a vacuum. Okay, so that fraction will give us a baseline to work from. Here is the one I gave you. Okay, right here. Your index for refractions. Okay, your indices of refraction. So air is given 1. From there you can see you have corn oil, diamond, ethanol, glass, all the way to zircon. These numbers will just tell you which one refracts light more. Okay, so you can see water, not bad. Not bad, refracts it a bit. You can still see through it pretty well though, probably. So we use this formula for these examples. This is the speed of light. Remember, c is the speed of light. This is the speed of light in that vacuum. And I can get you to solve for either one. So we'll just do this practice problem. It says, what is the index of refraction of a solid in which the speed of light is 1.24 times 10 to the 8 meters per second? Then you have to identify the solid, reference the table to do that. So what does this mean? Well, here's the formula. C you already know. You have to know this. It's the speed of light in a vacuum. Okay? I tell you the speed of light in this, whatever the substance is. Here it is right here. Much slower. We're looking for the index of refraction. Doesn't get any simpler than this, my friends. Here we go. You just do this division. Notice how units cancel off, and you're left with a small number, and that will be 1.24 times 10 to the 8. It is 2.42. Then you reference your table. Which one has an index of refraction of 2.42? You see it screaming out at you right away. That is diamond. Game over. Okay, therefore, this is diamond. Useful, hey? So if you can just measure how fast light travels in a medium, then you can know this. More importantly, if you know the index of refraction for a particular medium, then you'll know how fast light goes in that medium. Okay. So that leads us into, can you calculate how much bend occurs? So say this is a piece of glass, light's coming in at a certain angle, and it slows down or it bends, right? In some kind of way. Okay, hits it and bends and slows down a bit or something like that. Okay, and then it comes out and speeds up again. Okay, how much bend? What's the angles here? What's going on there? Can you predict that? That might be important if you want to build something. So that is formulated by something called Snell's law. Now Snell's law is sine of theta I, which is the angle of incidence, over sine of theta r, which is the angle of refraction. N is, of course, your index of refraction. So in these following examples, we make use of this formula. I can either get you to solve for these angles, or n. If you need to solve for the angle, you'll have to make use of the inverse trig function of sine, okay, sine inverse or arc sine. And so you can go through these examples. Hopefully they make sense. I will go through some practice problems with the more common version of Snell's law. This version right here, so you're not confused. Why do we use it? You use this when only one medium is explicitly, that's not how you spell explicitly, sorry, given, but I'm not going to change it. You get the idea. In other words, actually, the assumption is made is air is assumed to be the other medium. Now, what does this all mean? Well, air's index of refraction is actually 1, which means it would make no difference to any calculation. So here it says a ray enters a medium of unknown index of refraction. Well, it enters it from air. Okay, so who cares? From, n's 1 for that, so it doesn't make a difference. But let's say it's going from water to diamond. Say you have a piece of diamond in water. Okay, then what's going on? Well, then you actually have to care. Then you care about two separate indices of refraction that are not 1. So that's where this comes from. In this example, let's say this is like, CO2, just pure CO2. Okay, we're on Mars. And this guy comes up, bends. N2 will be some number, and 1 will be some number. That has to be into the formula. That has to be taken into account, and that's how it's taken into account. Okay? So, here we go. So if you're given two different mediums, you have to use this variation of the formula. So I'll do two practice problems with you right now. Light travels from glass into water. The angle of incidence in glass is 40. What is the angle of refraction in water? Oh, I'm nice, and I give you both these guys right here. I'm not going to rewrite them. So there's the index of refraction for water and the index of refraction for glass, hence the subscripts W and G. And I tell you the angle of incidence. This is important. Angle of incidence. Notice how it's not sine theta I. It's just theta I is equal to 40 degrees. There should be a degree sign here. Jeez. Okay. Looking for this. So the formula is the following. Sine theta r. Okay. Now you have to pair up which of these ends will go with I. So which one's the incident? Where's the ray start? It travels from glass. So it's starting with this guy. So you have 1.52 times sine of 40 equal to 1.33 times sine of theta r. Now you rearrange this. I'm going to write sine of theta r on the left-hand side, actually, because I prefer to do that. Basically, you're left with this situation, 1.52 sine of 40. I'm running out of room. I hate when I run out of room. Over 1.33. What you have to do here is you have to take sine inverse of both sides on your calculator. Okay. First of all, you can establish this to be a number. If you're using a Texas Instrument, so non-display, what I would do is I would go 1.52 times sine 40 divided by 1.33. You're going to get some long decimal expansion. Long decimal expansion. Then in your calculator, go second function sine inverse, and it'll spit out the answer. If you're in a display calculator, you can do the same thing, actually. Or you could type it in as you see it here. So you can go sine inverse of 1.52 times sine of 40, okay, divided by 1.33. You're going to have to close a bracket here, and you get an answer of 47. Okay, and it looks like we're at 3 sig figs, actually, 47.3 degrees. Okay, and there you have it. Okay, next question. If the index of refraction for diamond is 2.42, what will be the angle of refraction in diamond for an angle of incidence in water of 60? Ooh. Interesting. Okay. We're looking for this. Angle of incidence is 60. Okay, and here we go. So it says angle of incidence is 60, so let's start with waters. 1.33 sine of 60. This is the exact same type of question. You're at 2.42. I almost should leave this to you, but I'll give you the solution. Okay, you rearrange it just like usual. I'm just going to write this. This is typically what people do, just to let you know, is people typically don't like to write long decimal expansions on a page because it's annoying and it's not right, because you'll have to have a dot, dot, dot. So here's the exact answer, and then I'm just going to go right to the answer here. So we're going to have sine inverse of 1.33 times sine of 60 divided by 2.42 equals 20, and we're at 3 sig figs, 28.4 degrees. Okay, so that is that for Snell's law, and I'm going to stop there for this video. We're going to have a part 2 talking about critical angles. Okay.